Hello again. Back to vectors. We're now looking at 13F, intersecting lines. Okay, going right to example 13. This is example 13 from section 13F in the textbook. We have line 1, this blue vector equation, xy equals -2, 1 plus s, 3, 2. We could draw that if we wanted to. This would be the initial position, and that's the direction vector. Line 2 in this brown ink, xy equals 15, 5 plus t, -4, 1. And we need to find where do these two lines intersect. Okay, well, they're going to intersect when the x-coordinates are equal to each other and when the y-coordinates are equal to each other. Therefore, it would make sense that the point of intersection will happen when this x-coordinate and this x-coordinate are the same. Also, when this y-coordinate and this y-coordinate are the same. Okay, so therefore we're going to equate those. We're going to take the x component from line 1, so -2 plus 3s. We're going to set that equal to the x component from line 2, 15 subtract 4t. And we're going to do the same thing for the y components. So that's the x's. Now we'll do that for the y components as well. So the y components, 1 plus 2s for the first line, and 5 plus t for the second line. Okay, so now we have a system of equations. We have two equations with two unknowns. We can solve for s and t. We actually only need to find one or the other, s or t, because as soon as we know s, we could substitute s into this line 1 and find where that point of intersection is. Or if we found t first, we could substitute t here into line 2 and see where that point of intersection is. If you would like to do both, you can do both. You should get the exact same answer, and then that's a good check to make sure you have the correct answer. So if you have time on a test or assessment to do that, then you should do that. Okay, let's work with this system of equations. I'm going to call this equation 1, this equation 2. I'm going to simplify equation 1. 3s plus 4t, I'm just rearranging it, equals, so 3s, add 4t to both sides, add 2 to both sides equals 17. And equation 2, again, simplifying 2s, subtract t from both sides, subtract 1 from both sides, that would be 4. Okay. I'm going to use elimination, so I'm going to try to eliminate the t's. So I'm going to just copy down equation 1. And I'm going to take equation 2 and multiply it by 4. So that would be 8s subtract 4t equals 16. Now you can see why I multiplied it by 4, because I'm going to eliminate the t's here. When I now add these two equations together, 3s, 8s is 11s, 4t plus -4t is 0, and 17 plus 16 is 33. Therefore, s is 33 over 11, s is 3. Now I can take that s and plug it in here to determine the point of intersection. So this will be the point of intersection when s is equal to 3. -2 plus 9, 1 plus 6. That gives us 7, 7, which means the point of intersection, that's what we're asking for us. Where do they meet? So we're looking for that ordered pair. Therefore, they meet at this ordered pair, 7, 7. Okay, I'm just going to continue as if I had time on a test to double check to make sure I'm correct. I know that s is 3, so I'm going to plug that back into one of my original equations and solve for t. Substitute 3 in for the s. So I have t equals 2 Okay, now I can take that 2, substitute it here. So xy equals 15, 5 plus 2, negative 4, 1. 15 minus 8, 5 plus 2. And again, I still get 7, 7, which brings me to this answer. And now I know that my answer is correct. There we have it. That's how you find the intersection of two lines using vector methods. Have fun.